Okay, now this is an easy problem, so let us try. This is related to statics, basically equilibrium. So this problem is related to something equilibrium. So what this problem says, so let us listen the problem. So a ladder rests in limiting equilibrium against a rough vertical wall. So there is a rough vertical wall. So this wall is rough. And there is a ladder that is resting this vertical wall with its foot on a rough horizontal ground. This ground is also rough. This is given in the problem. This is also rough. So horizontal as well as vertical. The coefficient of friction at both points of contact is 1 by 2. So friction of coefficient is 1 by 2 at all points, at this point as well as this point, because these 2 points are point of contact. Now a ladder is uniform and weights 300 newtons. So weight of ladder is 300 newton. That is basically given. mg is given to you. Now ladder is uniform also. This is also given. This means masses are equally distributed. Find the normal reaction at the wall and angle theta which the ladder makes with the horizontal. So two things we have to find. This angle theta and the normal reaction at the wall. So this normal reaction. There are two things that we have to find. N, what is the value of n, and what is the value of theta. So there are two things that we have to find out. So how we will proceed. So let us first make the free body diagram. I can use this diagram even. So mg is acting from center of mass. That is a, let us say, length of rod is a, or it's easy if I take 2a. So length of rod is 2a. So length of rod, I have assumed this is 2a. So this means this length up to here, this length is a, and again from here to here, this length is a. Now this rod has a tendency to go in this direction, so there is a limiting friction force that is acting in this direction. So there is a friction force F acting in this direction. Now this has a tendency to go down. There is a friction force that is acting up direction. So of course these two friction will not be equal. So this is F1, this is F2. There are two friction forces. Now at this point there will be normal reaction N1, and similarly at this point there is normal reaction N2. So these two are the normal reaction. You see how many unknown we have. We have unknown N1, N2, and friction force. Since this is a tendency of limiting situation, so I can say in the limiting situation this friction force is mu times N1, and this situation, this limiting friction force is mu times N2, where mu is half. Now if I write the vertical equilibrium equation and horizontal equilibrium equation, I can write. So if I write vertical equilibrium equation, I can write the force acting in the vertical direction N1, and this force also F2 is equals to mg, that is acting downward direction. Now F2 is nothing but mu times N2, so I can write N1 plus mu times N2 is equals to mg. So this is my first equation. Now similarly I can write equation in horizontal direction. So if I write the equation in horizontal direction, what we will get? So there is a friction force F1 that is acting in this direction, N2 in this direction. So let us say this direction is a positive direction. So N2 minus this force is acting in this direction, that is minus mu times N1, because this is minus mu times N1. Any other force in the horizontal direction? There is no horizontal direction. So I can say the total force has to be 0. So N2 is nothing but mu times N1. So now I can solve for N1 and N2. So if I plug this value equation 2 in 1, so from 1 and 2, N1 plus, so let us find N1. Mu N2 is nothing but mu times N1. So this is mu times N1, this is equals to mg. So from here I can write N1 is nothing but mg divided by 1 plus mu square. So let us take the answer. So do we have answer? Okay, so answer for tan theta is given. So one, a normal reaction N2 is also given 120 Newton. So let us find N2. So N2 is nothing but mu mz, because mu N1. So N1 times mu. So mu N1 1 plus mu square, and mu is half. Mz is given to you 300 Newton, and this divided by 1 plus 1 by 2 whole square. So this comes out to be 150 divided by 1 plus 1 by 4, so 4 plus, so this comes out to be 150 divided by 5 into 4, so 30 into 4, 120 Newton. Okay, so this is the answer. Okay, I have checked the answer. This is the 120 Newton. The second point is we have to find out the theta. So I can take torque. So I can take torque at any point. So let us check, because this system is in equilibrium. So either I can take a torque toward this point, or torque through center of mass, or I can take torque through this point. If I take torque through this point, that will be beneficial, because I don't have to take the friction forces or into, or I can take from this point. Both are the same. So let us call this point as A. So taking torque about A. So if I take torque, this has to be come out to be 0, because this is in equilibrium. So if I take torque about A, this comes out to be 0. So let us say what are the forces that is. So torque about A, if I take, so N1 and F1 will contribute to 0 torque. Now mz in this direction, so mz into this is A, so this is A cos theta. So mz A cos theta, so torque is mz into A cos theta. Now this torque is basically acting in this direction, because this is a tendency to go in this direction. Now N2 is in this direction, and this length is 2a, this length is 2a sin theta. So N2 into 2a sin theta, so you can say N2, so minus N2 into 2a sin theta, and this is in this direction. Basically we have given the minus sign. Now this friction force F2, this is in this direction, and the distance will be this distance, so 2a cos theta. So mu N2 2a cos theta. Now this is acting in this direction. So this direction we have taken as positive, so this is positive, and this comes out to be 0. If I equate these forces, and N2, if I put the value of N2, N2 is the mz by 1 plus mu square, you can prove tan theta comes out to be 3 by 4. Let us check yourself whether you are getting the answer or not. So you solve this equation and you will get tan theta equals to 3 by 4. So try it yourself and you will get the same answer. Okay, thank you.